Hi folks, well today before we get on with any maths we're going to have to think about books a bit because it's World Book Day. So the book I'd like to bring to your attention today is Catch-22 by Joseph Heller, which is a great book. They made a really good TV series of it about a year or two ago, which I well recommend, which was an amazing feat because it was one of those books which I really think is pretty much impossible to do, but they just about managed it. But the book is all about an American in the Second World War who's has to fly missions in a bomber from the south of Italy, and he's having to do this every day, and he's absolutely scared of dying. He's always looking for a way out, and then he hears that it's possible one of the people who's flying missions with has definitely gone mad, and he discovers that actually if you're insane you don't have to fly, even though they keep telling you you've got to fly, but there is a catch, and that catch is Catch-22. So I'm just going to read you a little bit of that now. There was only one catch, and that catch was Catch-22, which specified that a concern for one's safety in the face of dangers that were real and immediate was the process of a rational mind, or was crazy and could be grounded. All he had to do was ask. But as soon as he did, he would no longer be crazy and would have to fly more missions, or would be crazy to fly more missions and sane if he didn't. But if he was sane, then he had to fly them. If he flew them, he was crazy and didn't have to, but if he didn't want to, he was sane and had to. Yossarian was moved very deeply by the absolute simplicity of this clause of Catch-22 and let out a respectful whistle. "That's some catch, that Catch-22, he observed. "It's the best there is," Dr. Decker agreed. And that's it. Now, the whole book is about, as it goes on, he starts to feel that Catch-22 is being used for everything. In fact, he starts to think Catch-22 doesn't exist other than as an excuse for people to tell him that he can't have what he wants. And that's often what life feels a little bit like. But anyway, we've got some maths to get on with. Right, so what we're going to do today is see if we can calculate a percentage of an amount without using a calculator. Now remember, it's always important that percentage means out of 100, which actually means divided by 100. And the percentage symbol itself was a way that mathematicians decided that they were wasting a lot of time. I don't know who decided this, but someone did at one point, writing divide by 100 when they're talking about percentages, when they thought, right, both the division symbol and the 100 are made of one straight line and a couple of circles. So they said, right, we'll have the one straight line still in the middle to represent that it's division with the zeros, but we'll have it on a slant so it's almost standing up like it is for 100. So that is a really important thing. When you say percentage and you just put a percentage symbol after a number, you're just saying that number's got to be divided by 100. But we're talking about it as a whole number instead of, if it was 86%, instead of talking about it as 0.86, 86%, it's nicer to talk about whole numbers, isn't it? It doesn't make our brains hurt as much. Right, so if we're going to calculate a percentage of an amount without a calculator, I've got a surefire way that can help us out by a grid. So this grid I would like you to draw down now. I'm going to start with we're going to make 7 boxes, and in the top box, I know I've only done 3 so far, I'm going to put 100%. In the box below that I'm going to put 50%, and in the box below that I'm going to put 25%. So what we need to think about is what calculation sends us from there to there. It's halving, isn't it? Because 50 is half of 100. And then 25% is half of 50%, so we can halve again to get 25%. Now that's all very good. How about moving across to the right as well? Another easy way of dividing that goes into 100 nicely, apart from halving, is dividing by 10. So we're going to divide by 10 in this direction. So if I've got 100% and I divide that 100 by 10, that's going to leave me with 10%. And if I do that again, dividing by 10 that is, 10 divided by 10 is 1. So that'll give me 1%. Now, I said 7. That was a lie. We've got 5 so far. I'm only going to put one more box in. But this box is the one that kind of makes this really, really cool as a technique, because it's going to work in two directions. If I had 50% and I divide that 50 by 10, 50 divided by 10 is 5. So that would give me 5%. Now some people like dividing by 10 more than halving, but others like to halve more than divide by 10, and sometimes one is easier than the other. Sometimes it can turn around. Half of 10 is 5, so we can divide by 2 going down here. Right, now I'm going to leave that grid in place for the rest of this lesson, and in the meantime we're going to work out some percentages of amounts. Here's our first problem then. What is 16% of 84? Well, what I'd like you to do is put that 84 in the 100% box, because that's our total amount, and we want to know what 16% of that is. And now pause the video and see if you can put the right numbers in the boxes below, following the instructions in red going in between. So hopefully you should have half of 84 is 42. So 50% of 84 is 42. Half of 42 is 21. So 25% is 21. 84 divided by 10 is 8.4. And 8.4 divided by 10 is 0.84. The digits stay the same, but just move one place over relative to the decimal point. 8.4 divided by 2 is 4.2. Does that agree with 42 divided by 10? Yes, it does. The digits are the same, but they've just moved one place over. Now, have we solved our problem yet? Not quite. But what I can do is I can say that I now know 10% equals 8.4. I also know that 5% equals 4.2 and 1% equals 0.84. Now why have I picked those three out? Because 10 plus 5 plus 1 makes 16. So if I've got the values for 10%, 5% and 1% and add them all together, I get what 16% is. Now I've got two decimal places there, so I'm going to fill them in there and there, do column addition. 0, 0 and 4. 8 plus 2 is 10, plus 4 is 14. 8 plus 4 is 12, plus 1 is 13. So the answer to what is 16% of 84 is 13.44. Right, now I'm going to challenge you to wipe out all the bits apart from or draw yourself another grid, and I want you to just going to change something here, and I'm just going to say the problem we're going to have now is what is 84% of 16. And whilst you get started on that, I'm just going to rub this out. I'm going to leave that bit there. Right, so hopefully you may well have gone and stuck 16 in there as your 100%. And now we're going to fill in the rest of the grid. So half of 16 is 8, so 50% of 16 is 8. Half of 8 is 4. 16 divided by 10, move the digits across one place compared to the decimal point, 1.6. And then making it smaller again, moving it over one more, 0.16. And 8 divided by 10 is 0.8, which is the same as half of 1.6. Right, now we've got to make 84%. So let's go for that as quick as we can. What do we reckon? So I'm going to go for 50%, and I've got 25%. That gets me up to 75. I need another 9, don't I? Do you know what? I'm going to put on 10% to get me up to 85%, and then I'm going to take 1% away in a minute. You could have done it in another way. You could have had plus 10 plus another 5 and then 4 more ones or whatever, I don't know, but that's the way I'm doing it. So my 50% is 8, my 25% is 4, and my 10% is 1.6. Fill in with one decimal place there with a 0. Add those together, we get 85% is equal to, we've got 6 there. 8 add 4 is 12, add 1 is 13.6. You know what, that's very close to what we had there before. Let's see what happens when we take 1% away. So taking 1%, 1% is 0.16, so I'm going to need another 0 in there before I do that. And now let's get rid of that line there. Oops. 6 from 0 I can't do, so I'm going to have to borrow 1 from the 6 to make that down to 5, and now I can do 6 from 10, which is 4. 1 from 5 is 4, 0 from 3 is 3, so we've got 13.44. Whoa! How about that? That's bizarre, isn't it? Do we think that's always going to happen if we pick any two digits? Well, let's try another problem and see if it does. Let's go for what is 99% of 1. Actually, no, let's make it 10. Let's be nice. Let's make it 10. 99% of 10. Pause the video, put 10 in the top box and see where you get to. Right, so we should have 10 there. 10% of 10, 10 divided by 10 is 1. Divide 1 by 10 is 0.1. Half of 10 is 5. Half of 5 is 2.5. 5 divided by 10 is 0.5. Half of 1 is 0.5. Right, now we want 99%. Now if I'm going for 99%, I could build it up with 50 plus 25 and so on. But the quickest way to do it is to say 100%. I know that that is 10. If I take 1% away, I will get 99%. Well, 1% is 0.1. So I just need to put a 0.0 in there. I can't take 1 from 0, so I'm going to have to go, oh, I can't take anything from there. So I'm going to have to go to here, and that'll make 10 there, and then I take 1 of that 10, leaving me with 9. And I take 1 from 10 is 9, and 0 from 9 is 9. So it's actually 9.9. Yes, if I take 0.1 away from 10, I've got 9.9. That makes sense, doesn't it? So that is 9.9. Now, you know what we're going to do now. What is 10%
of 99. Is that going to be the same idea? Well, actually, we do not need to fill everything out this time, do we? So if you excuse my fingers, if we just put in 99 here, since 10% is 1 here, that's all we need to do. 9.9 divided by 10, 99 divided by 10 is 9.9. So we've got it spot on, haven't we? And if you wanted to, you could say, oh, 0.99, what is 100% being 99, 1% being 0.99. When I take those away, does that actually end up with 9.9? And I've been rushing there, I'm talking nonsense, aren't I? Of course, I want 10%. So if I want 10% of 99, that would be taking away 90%. There's no point in doing that. What I'm talking about there is nonsense, so don't worry about that. Let's move on to a couple more, slightly more random numbers. So let's go for a couple of random numbers. What is 68% of 32? And we'll do that one the other way round as well. So pause the video and give it a go. So we want 68% of 32, so you should have 32 there. You should then divide 32 by 10 to get 3.2. Divide 3.2 by another 10 to get 0.32. Then halving the numbers. Half 32 is 16. Half of 16 is 8. 16 divided by 10 is 1.6, as is half of 3.2. Now we want 68%. So what am I going to take for that? I think I'm going to take 50% plus 25%. Plus, oh no, that's too many, isn't it? Let's go 10% to get me to 60, 5% to get me to 65, and let's just go real bog standard and say 1, 1 and 1 makes up to 68% altogether. So I'm going to have to do a bunch of adding here, and I'm doing this for a good reason actually this time. 50% of 32 is 16. We've got 10% being 3.2. We've got 5% being 1.6, and then we've got our 3 1% at 0.32, 0.32, 0.32. Now we've got to take care here. We've got to make sure we've got 2 decimal places by filling up with zeros everywhere else. I mean, imagine this was money. If it was £32, that's what that money would look like, isn't it? Add up the end, the pennies as such would give us 6, wouldn't it? 3, 6, 9, add 6 is 15, add 2 is 17. 6 add 3 is 9, 10, 11. Carry the 1. We get 21. £21.76. Now I'm going to leave that working there, and we're going to do 32% of 68. It's looking something like this, and then filling out the grid should give you something like that. Now to get 32%, I'm going to go for 3 lots of 10% and 2 1%. Which is less work, isn't it? And hopefully this should give me the same amount. So we've got 6.8, 6.8, 6.8, 0.32, 0.32. Fill in the zeros in the pennies column. 2 add 2 is 4. 3 eighths are 24, 27, 30. That's not the same, that's because I've done a silly and I haven't remembered that the 1% of 68, not 1% of 32. Add the 8s together, I do get 16. 24, 30, 36, 37. 3, 9, 15, 21. So I do get £21.76. Now this way wasn't that much simpler than that one, but sometimes it can be a lot simpler. So it's always worth, it is a genuine rule that always works. If you've got something like they're asking you for 59% of 10, you might think that's going to be really, really difficult. But it's going to give me the same answer as 10% of 59. It's the same thing, and I know that I can just do 59 divided by 10 to find 10%. So it's really, really worth remembering. Okay, we've got one more lesson on Monday before I see you all back in school on Wednesday, I think it is. Cheerio!